Let's look at the number of divisors of a positive integer. So we're not just talking about prime divisors here. We want to count the total number of positive divisors of a given integer. So here we're going to look at 24. So I'm going to think about this in terms of pairing divisors together. So I could write 24 as 1 times 24. So 1 is a divisor of 24, and so is 24. I can pair together 2 and 12, right? So 2 is a divisor of 24, and so is 24 divided by 2, which is 12. And I can pair together 3 and 8, and 4 and 6. So my total list of divisors here, I have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 positive divisors of 24. Another way to think of the number of positive divisors is to look at the prime factorization. So if I write 24 as a product of prime numbers, it's going to be 2 cubed times 3 to the first power. And each divisor of 24 has to be built from these prime divisors. Okay, so let's look at 2 cubed. 2 cubed is 8, and that has 4 divisors. 8's divisors are 1, 2, 4, and 8. 3 has 2 divisors, 1 and 3, and that's true for any prime number. We saw that in the table in the first video for this section. So if I use the fundamental counting principle here, to multiply, there are 4 times 2, or 8, total divisors of 24. Okay, so here's the list of positive divisors. So when I'm thinking about the divisors of 2 cubed, well, the divisors of 2 cubed have to be powers of 2 that are less than or equal to 2 cubed. So I have 2 to the 0, 2 to the first, 2 squared, and 2 cubed. My divisors of 3 are 3 to the 0 and 3. And so to get divisors of 24, I'm just going to take all possible combinations of those divisors that are listed up top. And there are 8 ways to do that. Okay, so in general, if I have P and Q are different primes and M and N are whole numbers, then the product P to the N times Q to the M is going to have N plus 1 times M plus 1 positive divisors. So here my P was 2 and my Q was 3, and my powers were 3 and 1. And so I had 3 plus 1 times 1 plus 1 positive divisors. And of course we can extend this to more than 2 primes. So if in general I have, say, K primes, P1 through PK, and N1 through NK are whole numbers, then the product P1 to the N1 times P2 to the N2, etc., up to PK to the NK is going to have, I'm going to take each of those powers and add 1 and multiply that together. So N1 plus 1 times N2 plus 1 dot 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 times NK plus 1. So let's see in practice what that looks like. So here I've already given you the prime factorization of this number in part A. 2 to the 4th times 5 to the 6th times 7. Remember, there's an understood to the first here. So how many positive divisors does this have? Well, it's already in prime factored form, so I just need to look at these exponents, and my rule says I'm going to take each of those exponents, add 1, and multiply. So I have 4 plus 1 times 6 plus 1 times 1 plus 1. That's 5 times 7 times 2. That's going to give me 35 times 2, which is 70 positive divisors. What about 40,500? Now I did not leave myself very much room here. I'm going to write up at the top. So I have 40,500. The first thing I want to do is find the prime factorization here. So I can think of this as 100 times 405. 100 is 10 times 10, and that's 2 times 5. 405 is divisible by 5. I get an 81, and that's 9 times 9. So what do I have here? I have 2 cubed times 5 cubed times 9 squared. And 9 is not prime, so I shouldn't have stopped there. I ran out of space and I just stopped. Each of those 9's factors is 3 times 3, right? So I have a 3 to the 4th. Now you should double check that you agree with what I just got. Oops, I wrote my 2's. So you shouldn't agree, my goodness. This should be a 2 squared, right? Let's look more closely. I've got 2 2's, 3 5's, and 4 3's. So 2 squared times 5 cubed times 3 to the 4th. All right. So let's use that. So now I've got it written as a product of primes. I just need to take each of those exponents and add 1. So I get 2 times 1 times 3, 2 plus 1 times 3 plus 1 times 4 plus 1. My goodness. And so what is that? I'm going to get 3 times 4 times 5. 4 times 5 is 20, times 3 is 60. So 60 positive divisors of 40,500. What about 1 million? Now instead of drawing the tree here to get the prime factorization, I'm just going to notice here that 1 million is 10 to the power 6. And 10 is 2 times 5. So that's 2 times 5 to the power 6. And my rule of exponents says I can pull that 6 in. So I have 2 to the 6 times 5 to the 6. 2 and 5 are prime, so I've got my prime factorization. So I'm just going to multiply 6 plus 1 times 6 plus 1 to get 7 times 7, or 49 positive divisors of 1 million.